So this is going to be a really quick video. This is Unit 6, Day 5, Rectangles, Day 1. I've already got a lot of this stuff written out for you, but basically we are going over rectangles, and as you can see here, rectangles are like a subset of parallelograms. So a rectangle is a parallelogram is a quadrilateral, and that's why I've got rectangles, this circle inside of a parallelogram circle, because technically all rectangles are parallelograms. And same thing with like all of this stuff deals with quadrilaterals. All of those parallelograms and rectangles are quadrilaterals, so I've got them both in that circle as well. I'm going to give you guys a second to write all these things down, then I'll talk about them. So if you unpause the video, quickly paused it, we're just going to quickly talk about these. So a quadrilateral is a four-sided figure. Parallelograms, 5 things have to happen for it to be a parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, or diagonals bisect each other. There's also one more that isn't listed here. You can have one set of opposite sides being parallel and congruent, but we'll get into that as we go through some examples as well. Rectangles. 2 things are true about rectangles. There are 4 right angles and diagonals are congruent. So yeah, diagonals bisect each other because that's true for a parallelogram, but the diagonals are also congruent. So if I were to draw a rectangle, I could make it whatever shape I wanted to make it. Okay, there's my rectangle. As long as I can draw straight lines here, and this app should help me do that. There's one of them. There's my other one. Those 2 lines are exactly the same length, and that's what that's saying. Diagonals are congruent on a rectangle. And that is our new theorem. So yeah, I basically just explained it there, but KM and JL are exactly the same size. Continuing, true or false? If false, give a counterexample. So first here, it says every rectangle is a parallelogram. That's true. Every rectangle is a parallelogram. That's why we have it in there. Because basically all 5 of these things are true for rectangles. These don't necessarily have to be true for all parallelograms, but all 5 of those things are true for rectangles. So that's true. Every quadrilateral is a rectangle. Yes, that's false. I'm sorry, that's false, because there are some quadrilaterals that aren't rectangles. For example, there's a 4-sided figure, a quadrilateral, that is not a rectangle. It doesn't have 90-degree corners. Next, every quadrilateral is a parallelogram. You're saying every 4-sided figure is a parallelogram? I don't think that's true, because I can make something like that. That's definitely not a parallelogram. Every parallelogram is a quadrilateral. Yes, every parallelogram has 4 sides, and yes, every rectangle also has 4 sides. So those bottom 2 are true. Now we're getting into some word problems here, or I guess not really word problems. We've got an image. It says in the rectangle below, EI is 3x plus 8 and FI is 5x minus 6. As you can see, I've already drawn in those items there. And then it says measure of IFG is 56 degrees. So I am going to, first of all, I've got to set this up. And the way that I can set this up is by knowing that HF and EG are congruent. My 2 diagonals are congruent and they're bisected. I then can conclude that this and this are congruent. In fact, for a rectangle, all 4 of those diagonals that are cut in half are going to be congruent. So I can just say 3x plus 8 equals 5x minus 6. And then I can begin to solve. So 8, I'm just subtracting 3x from both sides, subtract 3x from both sides, so I get 2x minus 6, add 6, so I get 14 equals 2x, so x equals 7. So if x equals 7, and we're trying to find, what are we trying to find? EG, we're trying to find this entire length there. So if I plug that 7 back in, 3 times 7 is 21, plus 8 is 29. I'm going to have to double that, though, because that's only half of it, right? So I need the other half, which is the exact same thing. So 29 times 2 is 58. So EG equals 58. And then we need EIH. So we need the angle EIH. I'm going to delete. Oh, I guess I can't do that. I'm going to erase these things because we're not talking about those right now. Actually, I can just erase everything except that 56 degrees. That's the only thing we need. We're trying to find EIH, this angle right there. So something that I need you guys to kind of understand with rectangles especially is that opposite, alternate interior angles are congruent. So that means that this one down here is also 56 degrees. Let me zoom in so I can write it, 56 degrees. And actually, another thing that's true is that every single triangle, this triangle, this triangle, this triangle, and this triangle, all four of those are isosceles. So this is going to be 56, not that one. And this one's going to be 56. And then since we know that these are 90-degree angles, we can figure out our other ones. So I'm going to try a different color with those. So this one would be, well, 90 minus 56 is 34. Yep, 34. Okay, so that's a 34, that's a 34, this is 34, and this is 34. Okay, so now we've got a lot of stuff figured out. The last thing we need to figure out is our angle that's right there. And since this is a, let me get my eraser out. Since this is a isosceles triangle and all triangles have 180 degrees, we can do 56. We can use these two 56s and add those together. And then subtract that from 180. And we get 68. So that means this angle right there is 68 degrees. I just subtracted those 56s from 180. So if that's 68, this one would be 68 because of vertical angles. And 112 would be that one. So we did a little bit more extra work than we had to, but that's all of those angles. We figured out all of those angles just by getting one of them. But you have to know that those are isosceles triangles. Next one, same type of situation here. I've got 4x plus 4 listed for you. That means that this one's also 4x plus 4. It says EI is 4x plus 4, so that would be like the E to the middle right there. So that means the other one is also 4x plus 4. So what we can say then, since we know FH is that entire red line there, I could say that 8x plus 8, if I add those two together, the 4x plus 4 and the 4x plus 4, is going to be equal to that 5x plus 29, because we know diagonals are congruent on a rectangle. You guys can solve for x there, and you can plug that back in and figure out IG. I'm not going to go through all that right now. I want to get into the measure of IHG. Where is that? I to H to G, that's right here. Okay, so the first thing that I would do is I would note, okay, well then if that's 37 and these are all isosceles triangles, then that would also be 37 degrees. And if that's 37 degrees, but this is a 90-degree angle, I could take 90 minus the 37, and I would get 53 for that angle. And that's the one that I'm looking for, so yeah, that would be my answer for measure of angle IHG. Okay, continuing. Next one, it says in rectangle LMO, LN equals 4x minus 17, MO equals 2x plus 13. That's how I would draw that, and I want to make a point here. I said LMNO, so I had to go in order from L to M to N to O in a circle. If you don't draw it like that, you're not going to get it right, but it's got to be in a circle with those letters. And then as you can see, I've got them labeled there. Those are the entire lines. So all you would have to do there is set those equal to each other, and you could solve for x. Continuing here for number 4, in rectangle ABCD, I went in a circle again. It gives me AC and CD, but CD is actually the bottom, as you can see. So I really, what I have here is actually a right triangle. Oops, I should use a pen. Here, let me see. I've got a right triangle here. So I can just use the Pythagorean theorems, which would be a squared plus 10 squared equals 12 squared. And I could solve for a, and maybe I can do that quick. It looks like a would be the square root of 44, which we could simplify to 2 root 11 through a bunch of simplification. I just kind of skipped ahead to the final answer there, but your assignment is listed on the bottom.